Yeah.
So, good evening. This is good evening from Europe. This is our transformative vertical flight meeting, public services. We are in November 2025, and our speaker this evening is Mr. Michele Sesana. Mr. Sesana is currently involved in digital innovation with TXT in Italy, and he's helping customers in prototyping and getting benefits of new technologies. He's a strategic developer and including virtual and artificial reality, artificial intelligence, Internet of Things. He is author of more than 30 scientific publications, and especially on Factory of the Future and Internet of Things. And I listened to Mr. Sesana a presentation during the European Rotorcraft Forum in 2025, and I invited him this evening to give us his inspirational presentation. So, Michele, the floor is yours.
Thank you, Marilena, for the introduction. Let me see if I can also start the video so you can see me. Thank you for the introduction. Now I'm going to, let's say, introduce a bit what is for us digital transformation. So our point of view on this, on the technologies that we think are most important for the aeronautics. And yes, as you introduced, I'm working on TXT as I'm the innovation manager of the company. So my goal is to support the medium long-term development of the company in collaboration with the business that usually has its own R&D focused on the short, medium term. So I'm the one that should support them, not in thinking version 1.1 or 1.2 of the software, but to think to version 3.0 to have something that is impactful in 2, 3, 4 years or even more. Let me share my screen. Just please tell me if you see it.
Yes, we see it, Michele.
Perfect. Thank you. As you introduced, Marilena, this content of the presentation has been presented at the European Rotorcraft Forum. I left also here the name of it, but let's say still actual this presentation. So just to introduce a bit what I'm going to present here in the next slides. So we are going through five steps. The first, if I'm able to go on with the presentation, sorry. Okay. So first of all, I'm going to provide you just a couple of slides to let you understand as much as possible our point of view, which is the one of a company, a digital enabler, large enterprise that works on core products and services of the customer. Just to let you understand which is our point of view, our lenses by which we look at the world. Then I will show you which is the process by which we keep an eye on the world, especially on the technological world, of course, to understand what's going on and try to anticipate and to follow the right technological trends of the hundreds that are available around. Then I will provide you a view on some of the technologies that we think that are an eye on are very important, are what is will be really impactful in the future. So the key technologies here you see in the box, a couple of them. Then I will go through quickly to the path that we follow to collaborate with others and makes the technologies not just technologies, but enabler of processes and new functionalities of product. So to be really innovative. Innovative in this case means really providing a fruitful outcome that could be less cost, more revenues, something new that cannot be done before. So what really makes into action the technology and allows to create something positive. And then I will have very few information about some of the collaborative research projects we have at this the stage on new technologies with universities, research centers, and customers. During 2025, we had more than 30 collaborative projects, closing, opening, and working running for the whole duration of the year. So this is more or less the path of this presentation. And so let's start a bit with our lenses. I don't know why I have some troubles to change the path, but okay. So let's see. I don't want to provide a group presentation, a long presentation, but just to quickly go through us to understand how we see the world. So I'll try to be as quick as possible. So we position ourselves as partner for end-to-end digital transformation across the whole life cycle of aircrafts. So we are about 3,000 professionals, about 300 million euro revenues last year, with a long-standing experience in aerospace. We work in aerospace since more than 30 years. We are a large enterprise. Headquarters in Italy, in Milano. We have offices spread around the globe to follow our customer. If you see, you can recognize Seattle in US. Boeing is there. Toulouse in France to support Airbus. In Bristol, we support the Westland part of Augusta Westland, now Leonardo Helicopters. So we follow customers all around the globe. We mentioned before that we recently acquired a company in Delft for the simulation software. Let's say we'll point it out here is the last number, the 15% investment in R&D. So we try to be technological provider, so we invest a lot onto new technologies. All the numbers that are here are public because we are quoted on the Milan Stock Exchange. So if you go on our website, you can find everything. Even quicker on this, that is a marketing slide, but just to note that we position ourselves as technology provider, technology partner. That's a bit the point of view of the whole speech. So we support digital transformation, our customer product and processes. So we do technological impact, technological innovation not on our product and processes, also on our products, software products, but mainly these are used to provide customers' product and processes a speed up. So some of the technologies are visible in the small circles in the picture on the right, and we'll find some of them in the next slides. We convey them in different ways. So you see the three big bubbles inside the circle. So we provide technologies through smart solutions, so software products off the shelf, let me say, software engineering, so development services. See if I try to simplify even too much, but that's to convey the message, and digital advisory, so IT governance advisory on how to manage processes, improve the processes. Here is just to mention that aerospace is defense is the root legacy of the company, but we work also on other sector too, and this is important for the innovation, and we'll see this in the next slides. So we saw the lenses, now how we are using them, how we do observe the world. So the 15% of investment I mentioned before in the introduction of the company in R&D are not decided by us autonomously, but arise from the continuous market analysis and discussion with customer partners, colleagues. As we say, there are hundreds of technologies in the world, hundreds of also buzzwords. We need to select the right one to concentrate on because the resources are always limited. And so we look at the market, we look at our customers, we discuss with them in order to prioritize. So select and prioritize some of them. In these slides, we describe a bit the market needs, the most important coming out from our customers interview, which are split on the left on product related challenges and on the right about process-related challenge. So the machine, the vehicle on one side, and the process on the other side. So looking at the products, first of all, let's say in today aerospace industry, we face increasingly complex challenges. So we are moving towards a multi-domain system of systems where platform must seamlessly interact across air, land, sea, space, and cyber domains. So multi-domain operation it's very critical right now. At the same time, autonomous flight is no longer just a concept, it's becoming a reality, bringing new requirements, especially for safety, certification, and integration. It's very, very complex, this part. So systems themselves are becoming more complex and interconnected, involving a much broader ecosystem of actors, or supply chain, stakeholders. So transversal to the previous bullets, the first one is the cybersecurity, which is seen as an absolutely critical point to ensure resilience and the trust across the entire life cycle, especially on data and communication. This is a more central point of discussion, because you can have the best technology in the world applied to the best process in the world, but if someone else from outside will overcome the barriers and will take control of your system, no more processes, no more software, the impact will be dramatically negative. So that's something that we see more and more important. It's not just from our side, of course, but asking to the customer, discussing with the customer, this is felt even more and more as transversal point to any of the other technology. Looking at the process-related challenges on the right, on the industry side, let's say the pressure for readiness and shorter time to market is stronger than ever. Everybody wants to decrease time to market. What some years ago was done in 3 years, now everybody wants to have it in 6 months, maybe not 12 months. So it's very strong the point to increase readiness and shorter time to market. Customer expect rapid development cycles, faster delivery of the solution, to mainly compress cost and be more competitive in the market. There is more and more, let's say, dynamicity on the market, and so companies want to provide the new products or new features on top of the products more often on the market. In parallel, the market itself is shifting towards a service-oriented model with integrated support. So here, the real value is not only in the product, it's no more only in the product. Of course, you need to have a good product, otherwise it's useless. But the real added value is the continuous service and digital capabilities to sustain it through its life. So product plus services, and in some cases also services. One good example in the last years of this is on the engine, not to sell anymore the engine, but to sell flying hours of engines. Technology trends. So on the annual basis, we engage our customer to support us on defining the technology path to follow. So again, to drive this 15%. So we ask several questions to our customer, but mainly can be summarized in what innovative technologies do you think are important for the near future, of course, for your business, to improve your business. So the results in the table are the summary of what emerged from the 2024 analysis. AI is, of course, the first stage, but there are also several other elements here to mention, like, for example, model-based system engineering, which was the third point. Of course, cybersecurity, as I mentioned before, is the second point, right after AI, but it's in 2024, 2025, AI is in the first position or positions everywhere, good or bad. But example, we have model-based system engineering, generative AI is increasing, we have certification by simulation, digital twin, VR. So there are a lot of technologies coming out from the service that we do with our customer. On the other way around, we don't look only to our customer bases, that, by the way, is composed by OEMs, by airlines, and first-tier supplier, mainly engine producer or part producers. And we recently added airports to the customer bases. By the way, we do this, but we also look outside. This is a KPMG report that was focused in that case on industrial manufacturing, but was not only on industrial manufacturing. You see in green the preparation of the positioning technologies for this, and in white is industrial manufacturing is on white, while in green there is the average of preparedness with all sectors. If you compare these findings with the previous slides, we see a clear alignment. So same technologies, AI, cybersecurity, data and analytics, VR, AR, cloud. These are also recognized as key priorities across different industries. Cybersecurity, if you see, is at the second place. AI is the third. Strangely, it's not at the first. It's the third here, but anyway, in the first positions. So let's not go much in details. So the message here is that the technologies that are being developed and highly funded in other industrial sector can also be leveraged in aerospace, so-called a spin-in of technologies from other domains. Of course, with the necessary adaptation to the specificity characteristic of aerospace market, especially the standards, the stringent standards of our industry. They can, doing this spin-in, the technology can become powerful enablers of innovation, competitiveness, also resilience of the aerospace. So these are, let's say, the technology trend from outside, from inside. Now let's look inside at what we see as most promising technologies. Of course, this is not excluding other technologies, but are the one that we prioritize inside our innovative projects and trying to, of course, get an impact on customers. The first is on AI use cases. Mainly here we are concentrating on computer vision and Gen AI. Again, here we have the distinction between product, service, and design and production process. So the machine and the process. On, let's say, from a product perspective, we see two priorities. In computer vision, supporting also sense of the perception of the autonomous system. And the second is on machine learning to support embedded autonomy. Of course, there are several challenges around them. Limited computational power. If I mount a strong AI algorithm on the drone, the battery of the drone that already is not, let's say, spanning for hours of lifetime, will be even more compressed. The other part is related of challenges related to the certification and non-deterministics of AI. So I must be able to certify an autonomous system. If I have something that is not deterministic, I cannot certify the aircraft, UAV, UXV, whatever. If you look on the processes, what we prioritize is AI to support model-based system engineering, supporting the validation of the models and the drafting of the requirements. So generative AI mainly that supports the model-based system engineering. Machine learning mainly to support predictive maintenance and quality control on manufacturing, of course, during operation on the predictive maintenance and the, let's say, effect of what has been manufactured and mounted on the vehicle. About software, we are looking for the auto coding functionalities that let's say, for a time being, are not enough, of course, to let's say, allow the AI to auto-code the software, especially if you're talking about aeronautic software. But there are several usage for automatic testing, requirements review, so there is space for generative AI there, especially for the testing part. And then we see it for AI-generated scenarios to support training and simulation. So there are several use cases that we prioritize here. And if you look on the outlook that we have for 2025, 2030, so what we see that is coming out is on the left, you see the certifiability of AI. So the AI that now is used in aerospace, mainly experimental level, to be trusted and certifiable somehow, of course, with some limitation. Here we are, for example, we are working on explainability algorithm. So the algorithm that is not a black box, providing you just the answer turn right, go green, breakage in, I don't know, 3 hours, but that provides you this information, but also gives you a precise information on which are the parameters that led to this suggestion or decision by AI, in the way that we can certify it because we know how it reasons inside. Second element is edge to maturity. Here we are working on embedding AI into processor in order to be able to have a real-time sensor fusion and autonomy on board. Of course, here the autonomy of the sensor can impact in the autonomy of the battery, as I was saying before. So this is a crucial element. In Italy, we have ST Microelectronics, which is also supplier of Apple. Has several sensors inside Apple phones. We are working with them to in some projects. Generative AI. Here we are thinking that generative AI that now is, let's say, starting to be used in a good or bad way. We think that this will be widely adopted in the future, especially for drafting requirements, code generation, automated testing, especially this one. The automated testing is what we see as low-hanging fruits for generative AI here. And what we see is that by 2030, AI will span on the full life cycle of the aircraft. And embedded will be an embedded standards across design, operation, training, also all over the value chain of the aircraft. As a second point, we have as a key digital transformation technology is the digital twin and simulation. Let's say the concept of the digital twin, of course, has been used in aerospace since years. What has changed recently is the maturity. So we have powerful tools, affordable computers, the integration of DI now let us to run a high fidelity simulation for both validation and rapid prototyping. So concretely, let's say aerospace engineering can spin up a twin of a digital aircraft system and test thousands of scenarios, let's say from component failure to extreme weather operations, maintenance intervention, whatever. And this allows to, let's say, to have several use cases that we can run to also have a stronger safety cases also before even bend the metal to build the aircraft of the future. So we don't have much time, but just to mention that we built the digital twin, for example, of Milan Bergamo Airport, which is the third in Italy for passengers. To be utilized by the Airport Operations Center to better understand awareness of what is going on on the airport, so not in the terminal, but in the movement of aircraft and everything else that is moving there, like tanks or fuel tank, escalators, etc. And to better react to problems, and we are going to add also AI capabilities on this in order to support the operators in taking a better decision. On the right, we have also the virtualization and certification by simulation. So simulation can be utilized also to certify virtually the aircrafts, allowing to reduce cost and time to the market, thanks to the fact that I can virtually test thousands of scenarios, and so speed up the development. Here we inserted some numbers, 10 to 500 times faster, depending on the how this can work in the future. Third technology is autonomy and automation. So on the autonomy side, we see the system that is closing the sense, plan, act loop. So computer vision and multi-sensor fusion that are born from automotive, for example, and electronics are enabling UAVs, ground vehicles, and even spacecraft to operate with greater independence. So the challenges are real, limited, as I said before, limited onboard computational power, the difficulties of certifying non-deterministic AI, as we mentioned before, but guidance from EASA, AeroCAE is paving the way for trustworthy, certifiable autonomy in the future. So the impact of autonomy, is the new application allows to move on in application like UAVs, UGV, advanced air mobility in general. If you look on the automation side, we should look at what manufacturing has done in the last years. Before with the Industry 4.0 and recently with the Industry 5.0, and replicate it to aeronautics. If you look on the Industry 4.0, essentially with the connectivity, everything that can be automated has been automated. So during the Industry 4.0, the personnel in the factory was not kicked out from the factory, but the role has been reduced a lot. While the goal in Industry 5.0 is to bring back the human in the factory, if you want to be to push this concept. So the human is back in the center of the factory, but is a human connected to IoT, data sense, information sensing from the machineries. We have AI supporting the human. We have augmentation by augmented reality or advanced HMIs that allow us to do more. So this is something that is running on manufacturing since a lot, and is now starting impacting also aerospace, where of course the number of production are not the same as the manufacturing of cars, for example, but the digitalization of processes with cobot, automated inspection, predictive maintenance, digital twin integration, etc., is something that it's coming, if not here already for some cases. For about autonomy and automation, the outlook that we have 2025-2030 is about to follow the drone strategy 2.0 from European Commission to have industrial robots in operation, digital factory, so the digital twin of the factory that can operate and support any decision about the production in the factory, certifiable AI, as we already mentioned a couple of times. That will be very, very important. A fourth example of key digital transformation technology is model-based system engineering. MBSA is not new. CSML is here since 2007 as a common language to model complex system. The The real step change now is the integration into a multidisciplinary environment. So we connect this model into a functional digital twin and into a digital thread spanning requirements, design, integration, verification, and operation. So this delivers end-to-end traceability, early risk of retirement, and a single source of trust shared by the value chain, like OEM, first-tier supplier, operators, and if you want to say, with governance, versioning, data integrity, supports also the certification by simulation. So the outcome here, the future, is to have a higher quality, shorter time to market, and evidence-based decisions. Exactly what, let's say, aerospace needs here. On this, the outlook for next year is to focus on factory twins, extended reality training. So extended reality, I think we all know, it's a mix of augmented and virtual reality. So parts of the training are virtual, but some others are physical. So I can touch the elements. If I want to get trained, I need muscle memory. It's fine with VR, but if you need muscle memory in managing something, mounting something, it's necessary to have extended reality, so to be able to work with our hands to see some parts of the training as a physical element. Virtual compliance, and of course model continuity and interoperability with the SysML in version 2. If you go on, let's say these were, let's say, the four major technologies. Now what I would like to talk a bit about, it's the path that we follow to realize the digital transformation. So we talked about the technologies, but the technology by themselves doesn't mean anything. We need to put them into operation to have something positive that should happen. So to really innovate, made an impact, we need to insert them into processes, into product, have new functionalities, change the processes, digitalize them. In this slide, I'm presenting which are, let's say, the major driver that we follow to make this happening. The path to be chosen is not, of course, just one, could be more than one, but mainly depends on several elements, and especially from the TRL, the technology readiness level of the technology. We can position from, let's say, top down, from the low TRL to high TRL. So first of all, let's say the project complexity is increasing every day. So to innovate, we need to open several collaboration with university, research institution, especially again where we are talking about low TRL. So we are a company, so we don't work in very low TRL. We don't work at TRL 2. We don't work at TRL 3. Even we start collaborating with university and research centers from that level, but we are not the expert of low TRL. But we need to be aware, to collaborate, to be aware of them, to understand the technology since the beginning, even when they are at TRL 2 and 3, and to be able to be among the first to pick them up and raise the TRL level. In several cases, it's also necessary to prove the fact the technology is working and which are the effect of the technology to customer, and let them get mature time by time. For this, in several cases, we utilize funded projects at national level, European level. We have European Commission, European Space Agency, Italian government, German government. So we have several projects with pro and cons depending on the institution that provides the funds. So these are a typical way that we use to start checking them, experimenting them, even with customer in this research project, in order to get acquainted with them and really put our hands on and understand which are the real value added and the real pains in using them. As a third point, we are a large company, as I said before, but we don't know everything. especially in this very complex world. So for us, in addition to research institution, we also collaborate with technology partners, startups, for highly specialized niches that we do not cover. We are not the expert on this. These collaborations are necessary to overcome, again, the increased complexity of any innovation project. It's very multidisciplinary. So to innovate, you need a multidisciplinary approach. If you are talking, for example, of pilot training, here we don't need just development software capabilities. We also need psychological assessment of the cognitive states, for example, of the pilot. This is something that we don't have in-house. We provide technologists, not psychologists. So we have some collaboration with the psychology department of some university in Italy, especially to progress on this together. For higher TRL at the bottom, especially when it's necessary to prove on the field the technology, especially on board, of course, it's necessary to collaborate with OEMs, first-year supplier, especially when we work on core systems. Should be there, and we need to experiment this. This is very important, this kind of collaboration with the OEMs to have a real take-up and technological impact on their product and services. So on low TRL, we usually work with the research institution, university, but when the TRL is very high, we are close to TRL 9, we need to bring the potential customer on board for, let's say, really have a take-up of the technology. Here I go quick, but it's just to provide you a map between the technologies that I mentioned before and the relation with the second part of previous slides about funded projects. So on the screen, there is the map between our key digital transformation technologies, the one on the left, and the estimation of the budget reserved to them in the different topics of the European Defence Funds, the EDF 2025. The EDF are the major funding vehicle for the innovative technology in defense in Europe. We took the liberty to read all the topics and extract the part of the topic that were related to these technologies, and we tried to extract the estimated budget for the technology itself. So not for the topic of the call, but for the technology itself. And as you see here, we are talking about some million euros on the EDF 7 years funding. So we see that there is quite a match. And in fact, we also participate to several proposals here. These are your slides is about what I mentioned at the beginning. So we are working on several core markets, and this is important for our innovation. Why? So if you see on the right, the slide shows the increase of maturity of some markets for AI in this case, but this could be reflected on other technologies. So AI in 2021, the maturity of the market in 2021, and the maturity in 2024. That, of course, is increasing because people and companies are understanding what AI can do and maybe also what cannot do. Here, technology is very advanced, automotive a bit less, but second position, aerospace and defense is quite good, it's third. Now, while, for example, healthcare or banking and capital are the lowest ones. What does it mean? It means that the technology, especially the one that are transversal, very transversal to different markets, we can rely on other markets from aerospace and do spin-in of technologies, or on the other way around, spin out of technologies. For example, in our experience, looking on artificial intelligence, especially machine learning, we developed them at the beginning in the company in manufacturing. because in aerospace was very difficult to have a lot of data available because of the difficulties in getting the data, property of the data. So was complex to have very qualitative data. And of course, you can't change the running systems on board of aircraft to have more data. So we develop our knowledge about machine learning in manufacturing, where we have manufacturing execution system, for example, installed in 700 customers, more or less. And so we got a lot of data. Quality came a bit later, but at least we had the data. We started working on this on manufacturing. And then when we knew about the manufacturing, was time in which aerospace, we started having some data availability, some good quality. And so we used the person that has a strong knowledge coming out from manufacturing, we moved them into aerospace. So we have a sort of spinning of technology and the competencies inside the company. On the other way around, what was augmented, virtual, extended reality, we developed it first in aerospace, and then we move it into manufacturing. Why? Because in this case, virtual reality solves the problem of having a difficult access target system. We cannot do everything. An helicopter to be found, a drone to be found for training an aircraft is not easy. And so there was a strong need to virtualize several operations. So we built a lot of virtual reality training system. And then we started moving to manufacturing when there is several needs, but was not so felt as a strong need at the beginning. They discover after. So having the cross fertilization, cross transfer of technology sometimes is a buzzword, but from our experience is very important if you can rely on the specificities of the different market. And so in aerospace and defense, we can spin in and out several competencies and technologies. So we have several paths to make this happen. I give you some examples of collaborative projects, just few words about some of this, some of the R&D, RNI, Research and Innovation project. For example, in Arto, Arto projects, we are developing a cobot that is piloting an aircraft or an helicopter to do integration test. So when we integrate, we build a flight simulator, want to test it. And to test it as a human, we sit down in the cockpit, we read the manual, we put the aircraft in a certain altitude, in a certain state, and then we do some maneuvers and we check with our hands and we check with our eyes that the effect was the one that was supposed to be on lights, on sensations, on movements, all of this. So we don't want to see what is happening at digital level. We don't care about the variables. I need to see the lights which is red. I need to see the lights red. What is the behind? I don't need to do it. In this case, what's the problem? The problem is that this is prone to human errors. You can just do something wrong as human because you need to check a lot of parameters, so you can just be wrong on this. So what we are doing is that the person just defines which is the test procedure. The computer system puts the aircraft automatically to a certain altitude, to a certain state, so in the starting level, and the cobot does the same maneuvers that the arm of the person would have done. And so move the aircraft, pilot the aircraft, of course, moved with the computer vision because there is a camera, more than one camera that looks around and allows to, let's say, click the button, move the switch, the lever, the knob, whatever there. And the camera also with the computer vision checks that everything is happening. So the light is red as expected. This allows to, let's say, replicate these tests several times and having, let's say, the beginning of the day while these are run and during the night, the report of the 30 iteration of the test, and the human can just concentrate on what is important. Errors, for example. In Sophia project, we are adding artificial intelligence to interpret the human language on top of our platform that allows to build a VR application visually, blocks programming. So we have a product that's allowed to write VR with blocks programming. So this is a sort of meta language. What we are doing is to use Gen AI to let the subject matter expert describe the procedure, and the Gen AI transform this into the programming blocks. That was the meta language of this. In this way, we save a lot of time in creating, for example, maintenance procedure or operational procedures in VR. We just speak and magically the procedure is created. Of course, it's not magic, it's not 100% working, but we managed to have more than 70% time reduction in the creation of the virtual reality. So that's quite a lot. I mentioned before, so the Avio project, in which we are creating the digital twin. We already released the first prototype of the Milano Bergamo airport. That's the third in Italy for passengers, so not a small airport, even if, let's say, squared meters is not the widest. Here, again, we are relying on a digital twin at the beginning. So we perfectly present to the person what is going on in the airport, where the aircraft are, where the baggages are, every information. But at the same time, what we rely on is on the simulation and if cases analysis, AI introduction. So we'll build in the future several plugins, let me say, of the digital twin in order to support the daily operation of the airport. So these are, let's say, three of the others one, that more than 30 projects that we have open in 2025. If you have some hours, I can stay here to discuss a lot about that. But let's say, just to wrap up a bit on the takeaway messages. So what we can say is that digital transformation is, of course, no longer optional. It is the key enabler of speed, resilience, and sovereignty on aerospace. From our point of view is always the one to provide digital transformation as technology and domain expert on product and processes. We saw this in several slides. The lenses by which I presented you the slides up to now, again, are the large enterprise specialized in advanced technology. So technology provider, technology enabler. So is one of the possible lenses on digital innovation that we can have, but our lenses. Again, through the lenses, we need to observe. So I presented you what we are doing to have a technology foresight continuously, and the market analysis, looking inside the customer bases of TXT, and as well as looking on the market, relying on other reports that looks not only aerospace and not only our customer bases, but more openly the landscape of the technology in the world. I presented you 4 technology that we think are the most profitable in the future. Of course, are not the only one that you're following, are not the only one that will have an impact. So, but what I would like to convey to you is a bit of our reasoning about the technology. Then having this continuous observation, these key technologies, every time it changes a bit, priorities among them, or we add the new technologies. So it's a continuous process. So what I presented today is just a snapshot of today. The world is complex. Innovation projects are again more and more multidisciplinary, more complex, and so collaboration it's essential to do innovation. And I presented you a bit the different collaboration path that we have, from academia to customers, passing through different kind of collaborations. This is, I think, very, very important. Nobody is alone in the world. Nobody does innovation alone. But there should be a continuous exchange of information, of tests on also failures, in order to really get an innovation at the end. And let's say I gave you a few information about the several projects that we have open, but we are really investing a lot in these collaborative projects. We have again 30 more than 30 in 2025, because it's a way to really experiment, fail often and sooner, as we say, and really understand which are the really value added of the technologies in our world, in aerospace. So this is all from our side. So of course, if there is any question, discussion, open points, I'm here to answer, or at least to try to answer to this.
Thank you very much, Michele. Thank you. So let's see what questions there are first.
Michele, this is Johnny here. Quick question on some area you talk about, including the sensor fusion, AI processing. Does that where you think we stand today from aviation application? Yeah, of course, we talk about electric vertical takeoff landing aircraft, short field takeoff, advanced technology airplanes. Are we at the beginning, early stage of enabling the sensor fusion and AI interpretation and help navigate or collision avoidance at this point? Or are we in the middle of the development? How far are we into that capability?
It's a very good question. I think we in not just us, but in the world, we as humanity, I think we develop already a lot. I think we are quite at the beginning, because the autonomous system are more and more available. The technology is progressing a lot, so everything is becoming autonomous, more or less. So I think we are quite advanced. At the same time, I think we are quite still at the beginning. The real blocking barriers we see is what I already mentioned it several times, is the certifiability of the systems. Because when you want to really fly with, I don't know, let's take the example of the drone on the cities and urban environment that provides the mail to the people. Here, okay, it probably can work already now, very autonomously, etc. But the legislation is not allowing, at least in Europe, not at all for this. So that's the real big barrier, and includes AI and the non-deterministics of AI.
Yep. Agree. I understand. Thank you.
Thank you. I see
I think
raised hand from Nick.
have a question.
Yes, Michele, thank you for a very informative talk. I wonder, in thinking about how we'll be progressing and how we can move speed into the equation, as you've discussed, how would you think about getting governmental approval, which you just hinted at in your last answer? How would we get that government approval to be made more timely and maybe more collaboratively in the future? Do you have any ideas of how we can construct our path forward?
You mean with EASA or FAA?
Indeed, yes.
Yeah, I can answer for EASA at least. So in EASA, there has been, for the certification, has been created a new framework. That, of course, is something that is not speeding quickly, but they started creating, and I'm not the big expert here, but we are working with Polytechnic of Milano, in which they have several discussions open with EASA. EASA is creating this framework in order to allow the certification of new kind of aircrafts. The revision for this is ongoing, and also on new technologies. For example, they are now allowing to start the certification of flight simulators in VR, one of a kind. So you need to have a sponsor for this. So you carry there the item, and they're working. So there is something that is working, as is let's say running. Of course, the speed of certification authorities is the speed of a certification authority that, of course, need to take also. It's also necessary, let's say, not to rush, but to think a bit more and have safety first approach. So I think there are some working groups here. Probably we need to have a speed up on these working groups.
Thank you.
I got a question, or I guess
Sure.
a comment. A friend of mine is retired from Microsoft. Where he was a software engineer for 25 years. And he's retired now. And just for fun, he tried AI coding. And he was surprised how fast it was. And anyway, it occurs to me, you know, you talked about one of the costs being certification. And would it be a quicker path to software certification if you used AI, but on a very carefully database that the AI was, the software database that the AI was trained on? In other words, see, all AI does is it just grabs past successes. It just grabs them and puts them in, and makes code very quickly. But if you training database is like a certified training database, then maybe the software that results from that AI might be much closer to final certification than if you don't certify the database that the AI was trained on. You understand the concept, or?
Let me see if I understand. In this case, we are not trying to, let's say, to certify the AI that could be non-deterministic, but we want to certify the code that's been created by AI in this case.
Right.
So,
but if the AI is trained on a very accurate, almost certified database, if it's trained on, it might go further to certifying the final software.
Yeah, let's say that there are two levels. If you get Gen AI, even if it's trained on a certain data set, every time can provide you a different answer, a different generation of code or images or other stuff. So this is more complex to be certified because it could be non-deterministic, even if it's trained on the certified data set. But the way the Gen AI creates something is always different. What has been generated by AI, if it's a piece of code, AI works since computer science works since the beginning in black boxes. So if you have a piece of code, this is in a sort of box, in a black box, and you can always certify it because you provide all the test cases at the beginning you observe what is the output of it. So in this case, if the source code is certified by AI, even without opening it, you can be sure of a deterministic view on it. So you put inputs, you get the output for this. The problem with generative AI code, because we are testing it continuously, of course, is not much to write it, but if this doesn't work, it's very, very complex to find where the problem is. At this stage, 20 of November 2025, in 3 days, I don't know what can happen. But what we observed is that for small cases, AI generates a good code. In other cases, no. And if there is a problem, it's very complex to find the problem. You would have been faster to write by yourself. That's the stage, but let's say AI is running very fast, so I cannot say what will be there in 1 month. Let me say, at least this is my experience, not something sure. I don't know if I answered to your question. I misunderstood the point.
Well, it was just an idea that if you train your coding AI on a high quality data set, it might make the final certification of that code better, easier.
For sure, we'll be closer to the certification, of course.
Yeah.
Gold in, gold out, garbage in, garbage out.
Yeah, that's all I was driving to.
Sure. I think, well, we'll see this in not many years or months.
You know, I was trying to add that with this AI, now, so you need to ensure the robustness, and that's the problem. And that's also our problem with advanced controllers. And because, yeah, they function, but yeah, in some cases they do not. And that's the problem. This is why we still use in a classical control system very classical robust control and not other non-conventional advanced controllers. And that's also the problem of AI.
I think listen to what Tal was talking about. Am I interpret your idea in that, for example, if we have a specifically narrowly trained AI coding system, only trained on aviation DO 170A certified software in the past, he doesn't know how to code anything else. Will he come up with the same old 170A certifiable coding as a result?
Yeah, well, that's one technique, related to the idea. Yeah, it's just it's the old saying, garbage in, garbage out. And if your AI training is on a high quality data set, I would think that your output would be high quality as well. I mean, there still may be mistakes, but hopefully, if the AI was trained on a high quality data set, that it would tend to give you high quality results. That's all I'm saying.
From what I know is that actually they train those AI even with fake data in order to make it better. So it's not like it's not like analyzing flight test data. If you have very high flight test data quality, then you get a very good model. So there is something more. They train those algorithms with fake data in order to get better algorithms.
How does that? How does the fake? When you say fake data,
Synthetic data.
Yeah, synthetic. Yes.
Okay, but is that accurate synthetic data, or?
There are different techniques, but mainly you train an algorithm with something real, and then you ask to then from this derive the synthetic data. So it's a way to enlarge the data sets.
And to help Michele get out of this tree, let me suggest that that's far beyond the scope of this discussion is how to qualify AI. And I think I could have another whole career trying that one out.
No, but I think this is a very important point for the next years.
Indeed, absolutely.
Thank you very much.